Hello, 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 hello. Do 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 do. Yes, dude, it's fancy. Fancy, fancy. You're on screen. Hi. Okay, so I have these assets that Miko gave me. This is Katachi. He has 3 movement frames for each direction, and I have 1 background and 1 cupcake item. So here's what we're doing. We are going to be making Katachi able to walk and explore on this map, and for him to be able to encounter and interact with the cupcake, but not step over it, because it will be an obstacle as well. Okay? Sound good? Let's do it. So the first thing I'm doing is I'm going to check the specification that Miko gave me. So we're going to have a grid or tile-based system. The character will stay centered on in the screen, whereas the map will move underneath him to show him moving against the map. An enter key pressed next to and facing an item interacts, and items are obstacles. So that is my specifications. So let's get started. The first thing I'm going to do is I am going to work on creating some class structure. I'm going to start thinking about what size my tiles should be actually. So I'm going to take a look at my images. And Katachi is 79 by 136. 70! Miko, why would you make it 79? Well, whatever. Fine. Let's just say 80. Let's say we're going to have 80 by 80 grid tiles. They'll be invisible, of course, but that's what they'll be. So then some calculations. Calculator. I have a 1280. And if I divide that by 80, that's going to be exactly 16. So I'm going to have a 16 tile wide area. So that's cool. Let's put that down there as a note. And then let's do, what is it, 720? 720, also divided by 80. Hey, that's 9. Okay, cool. So we have a 16 by 9 grid, basically. Or we can have bigger, but we're going to have that much showing on the screen at one point in time. Okay. So the next thing I'm going to do is I'm going to think about how I want to store the information. So I have what was I going to say? I have a map in mind, and it's usually when you're doing a 2-dimensional map, it ends up being a 2-dimensional array, because that's just one of the most natural ways to think of it. So let's start with an actual map. House map equals, and it's going to be an array. And let's check how big our image is here for the background. 1488 by 960. Man, you make stuff in weird sizes. 1488 divided by 80. 18.6. Okay, so let's call that 19. 19 tiles wide, X, and the height was 960. 960 divided by 80. 12. Okay. 12 tiles tall. Sweet. So then I'm going to basically make an empty grid at this point that is going to be, well, let's think about what information we want our grid square to have. So I'm going to do I'm going to get rid of this for the moment, but we will background map. So, okay. Init Python, and I'm going to say class map tile. Sure, why not? And then we're going to say def init, and we'll take our self and we'll take an item, and we'll say that starts off as none. So self.item equals, or well, let's not call it item because it could be a person, so we'll call it occupant. Occupant equals, yeah, occupant. Okay. Yes, it says I'm streaming. Okay, cool. I guess just nobody's talking to me. Okay, so that's our very basic of basic. We have to know who is occupying the tile. Now, since these tiles are not an individual... Hello? Are we okay? Are we okay? The stream is continuing. Hello? Hello? Okay, let's see. Let's go back. Poor Miko. Okay. Yeah. So let's get back to it. So let's start with just that. It's just going to hold on to that. It's going to get more complicated later. I am absolutely sure of it. But we'll start with that. And so then down here, I'm going to say default house map equals a list. And in that list, we have 12 rows, so that's going to be 12 of these 12 lines there, and each of them is going to have 19 in it. So, yeah, I'm lazy. I'm just gonna... Okay, never mind. Let's do that procedurally. House map equals empty list. 4 in range 12. New row equals 4 J in range 19, because we got 19 columns because that's the width, And we got 12 rows. That's the height. It seems backwards, but you'll get used to it when you do these things often enough. And then you'll still get confused anyway, but less often. Okay. So then, we're going to say new row dot push. Oh, that's sorry, wrong language. Append map tile. And we don't have to give it an occupant. This will be an empty tile. Okay, cool. Okay. So then after we have filled our row, we're going to say house map dot append new row. Okay, so I have procedurally filled my house map, which is okay because who is calling me? You know what? I don't care. Go away. Okay. Where was I? Okay, so we have filled in our map with blank tiles. That's nice and all. Let's make Let's make another class. I'm gonna call this asterism map because I'm pretty sure there's something called map already, and I don't want to collide with that. Let us say def init self map and image. Oh, wrong language again, sorry. I've been programming in a lot of JavaScript lately. Okay. So I'm going to say self.map equals map, self.image equals image. And so right now, all we're doing is storing our map, which is this house map right here, or which will be, and our image, which is that right there. So let us say what shall we call it? Katachi's house equals asterism map. Let us give it house map, and then we're gonna give it what is it called? What is it called? Katachi's house inside PNG. Okay. Come on. What is your problem? What is your problem? Why do you not click for me? There you go. Okay. Okay. So now we have associated our set of tiles or our data with our image. Okay, so that's cool. So then we're going to have to think about something like, where is the current character? Because there's only ever going to be one player character on the map at the time. At least I hope so, because otherwise that would be very confusing. So then we're going to say let us say self dot center equal, oh, let's do center x equals, we will start with map dot length of map 0, which is of course the 19. And then because we don't want to do that, we want to divide that by 2, which will give us 10. Cool. Center. And self dot center y equals length of. Yeah, well, no, let's allow for starting wherever. So let's say start x and start y, and we shall say self dot center x equals start x, self dot center y equals start y. And now what? Yes, thank you, Miko. Okay, so hold on one second. My cat is attempting to destroy my furniture. Debutante, what are you doing? What are you doing? You want food? Alrighty then, sorry about that. Okay. So, no, go away, Twitter. The way I'm envisioning this happening is that our start position is where Katachi is going. Hi, Zuzu. Is where Katachi is going to be entering from. So let us take a look at where the actual. Let's take a look at this picture. Okay, so let's say Katachi is coming in from right about here. That looks to me to be slightly over halfway, so I'm gonna make a guess and say, oh, column 11 maybe? Why not? So that's gonna be 11, and I guess 11 for the row as well. Thank you, Justy. Okay. Because 11 is the bottom of the map in Y terms. Okay. Oh, I spy a Nye. Hi, Nye. Did I break your cover or blow your cover or something? Okay. So now that we know where we're going to start from, we got to start thinking about how we're actually going to display Katachi. So I'm going to make a new file for that. New file. And I'm going to make it spaces, and I'm going to call it, I need to be in the game, please, Katachi.rpy. Yes, that's very nice. Okay. So here be my images. I'm going to set up the different animations for that. And I'm going to say image Katachi up, north, what? Back. Let's do back. Yeah, that's fine. Back equals Oh, not equals. K back 1.png. K back 1.png. Let us give it 0.15 seconds. Why not? We can fix that later if it looks bad. Let's give it 0.2 for that, so he takes a tiny little extra pause in between walking. Why not? Deb, what are you doing? Whatever. You're having fun. That's what matters. And then we go back to K back 2. And we pause again for the 0.2. And then we repeat. And then we do the same thing with the others. Katachi front. K front 1. Yes, that's right, Deb. K front 2. K front 3. K front 2. And repeat. And what is it, left and right now? Yes, it is. Okay. Okay, so image, Katachi left. No, not K front, K left. And then let me put in the third one if I can spell. And then I shall put in 2 again if I could spell. And then I shall have 1 left to do. Katachi right. And K right. Oops, 1. K right 3. I swear this is probably the most tedious part of it, just because I'm being lazy and I don't want to write a whole function just to make a 3 for animation. Okay, so then we're going to say image cook. Let's put that up at the top. Let us say default K direction equals front. So he starts off looking at the front. Image Katachi equals Katachi K-dir. Okay. So that means that when K-dir becomes front, it's going to show the front facing Katachi. And likewise with back, left, and right. Okay, so that is our Katachi image setup. And let's see, what shall we do next? I think what we need to do is think about how we want to... Hold on. Daddy Funk, what is your problem? Don't whine at me. Okay. Hopefully my cat will be quiet now. Are we still on? We are still on. Okay. So, the next thing I want to do is I want to think about how we're going to position Katachi on the tile itself. Because Katachi is not an 80 by 80 sprite. He's just not. He's too tall. So I usually find that people tend to walk from their feet instead of their heads. So I would like to put his feet in the tile, the actual relevant tile, and then his head can just sort of go above or whatever. So that's cool. Let us say, okay, so he's 134. Why is he different sizes, Miko? Why? Miko, why you do this to me? And he's 138 here. And he's 70. Oh, no. Miko. Well, at least left and right are self-consistent. Okay. So let's err on the side of it being 136 because that's the average of all of them. And it's in the middle and they're only off by 2 pixels at most. So let's say if I want Katachi's feet to be, let's say, 10 pixels above the bottom of the tile. So I want, or, well, no, he's got a little space there. He can be at the bottom of the tile. Okay, so then the top left corner of the tile is, let's say, at 0, 0, relative to the tile, of course. And Katachi's feet need to be at the Katachi's bottom left corner needs to be at 0, 80 for it to be at the bottom. So then, where does his top left corner need to be? His top left corner still needs to be at 0 for the X, but for the Y, because we're going up more, we have to say, calculator, please help me because I can't do math on screen while I'm online and on the camera. And minus, oops, 136 minus 80. 56. We need to go 56 pixels above where the tile starts in order for Katachi to have his feet in the right place. Okay. So I'm going to put that right there. Define K offset equals negative 56. Why negative? Because we're going up. We are, it goes from top to bottom, 0 down. So that's what we're doing. So then, what is next? We need to, let us say, yeah, we can start just mapping it out. So let us make a map screen file because I like to keep things neat-ish. Map screen.rpy. And it shall have a screen, and it shall be called map screen. And it shall take in a map. No. A map. Sure. Asterism map. Okay. So what are we going to do here? The first thing we're going to do is we're going to put the background image on. But where? Because we want the background image to be moving based on where Katachi is. Because we want Katachi to always be in the center. So, what does that mean for us? That means that we need to check where our center is, because that's Katachi's location. And we need to make that be in the center of the screen. So, let's do a couple examples. I'll just write them down here. So let's say if Katachi is at 4-3. Let's say Katachi is at 4-3. Then we want the fifth grid, or fourth, depending on whether you want to start from 1 or not, but I'm going to say that's the fifth one. Because I start from 0, and it's normal to me now, so there. So, we is going to say that the fifth one is center X is 4, but the center X in pixels is 80 times 5. So what's that? 80 times 5, 400. Okay, so in this case, we would want wherever the 400th pixel is along here to be centered in the Ren'Py screen. Because that is, we would want that tile that begins there, goes from 400 to 480 to be centered. So let's take half of that and turn it into 440. Okay, so that is the location on my image where that should be put in the very center of the screen in the X alignment. How do we translate that into where should the image go? So the very center of the screen is 1280 over 2, which is, oh, come on, I can do this. No, I can't. 640. Yes, okay. So if we want our 440 from our image to be at 640 on the screen, we had better start 200 over to the right. Yeah? Okay? Okay. So then we say X position is going to be center of screens, which is always going to be constant, 640, minus center X in pixels. Okay, yeah, let's add that there so we don't forget that we actually did that and you guys don't think that I just can't do math. Okay, so in this case, it's 200. Let's do the same thing with Y. So for 3, that's actually the fourth one. So center Y in pixels equals 80 times 80 times 4. And we're going to do plus 40 again because once again, these are 80 by 80 squares. So equals 360. Yes, 360. Hey, Joey, I see you there. Okay. Okay, so 360 is there, and then the center of the screen is 720 divided by 2, which is that 360? Yes, it is. Well, in that case, they line up perfectly, and we would want an offset of 0 in the Y position. So our Y position equals center of screen 360 minus center Y in pixels. Okay, so what is the point of all this? How do I actually code it? So what I'm going to do is I'm going to say the very first thing, add a map dot image. Add that image, that background image. But where do we add that background image? So I'm going to do some calculations in here. I'm going to say that X, I'm going to call it offset X. Offset X equals 640, because it's always 640 unless I change the whole size of the game, which I'm not going to do, minus. And then we have our calculation for our Katachi location. So notice how we are doing a multiplication by one more than our list index. And that's because we started 0. Do we actually want to do that? No, let's not do that. Let's do it this way. Because we actually want to do that. And then so that's going to be 360 here. And this is going to be 80 less than that. So that's going to be 280. Okay. And the reason why we're doing that is because if our center is at 0, 0, we want the center of the 0, 0 tile to be in the middle. Okay? Okay. Cool. So before I even do that, I'm going to say add some black just to make the screen not transparent, because that would be weird. Okay, so we're adding our map.image and we're calculating our offset for X. So it's going to be 80 because that's our tile size. So feel free to abstract these hard-coded numbers into variables. That is the smart thing to do. And the only reason I am not doing it right now is because I am lazy. And because this is a prototype and I'm trying to go fast so that you guys don't get bored. Okay, so times a map dot center X. That's what I called it, isn't it? Center X. Yes. Center X. And then plus 40. So I could just be 680, but whatever. Okay, same thing for the offset. Y equals 280 minus 80 times a map dot center Y plus 240. Okay, we have our offsets. What do we do with them? So remember how I said that, so the difference now between these guys is not 200, it's 280. But the principle remains the same. I want to be at 280 so for my leftmost edge, so that I can have my middle, my correct tile at 360 be mapped up to 640. Once we see it, I hope it will be a little less abstract.
and confusing. And trust me, it always starts off abstract and confusing until you get used to it and do this a lot, because that's just math. You gotta make it concrete before it can mean anything to you. So I'm gonna say position offset X offset Y. Okay. We have added it. It is all good. Now we have a background in the right place. But we gotta add Katachi. Okay, so let's add Katachi. We gotta add Katachi to our map. Okay, so let's back up a second. We've got our background in place, but we're gonna need some kind of thing to represent objects or items or occupants on the tiles. So let's make another class. Let's call it I kind of want to say something edgy, but never mind. Class map denizens. Sure, let's do it. Def init self x y. Oops. Okay. Self.x equals x. And let's do an image as well so that we can actually display it. And let's see. Let's do a width and a height too. Self dot y equals y. Self dot image equals image. Self dot width equals width. Self dot height equals height. Okay, we have saved everything. And let us make a function so that we can calculate on the fly where this thing should be. So when I make Katachi, this is the offset thing I was talking about. This -56 business is going to be the offset, is going to be what's used for the calculation for that. So, well, let me just say, I'm going to put right here, I'm going to define tile size equals 80. Sure, why not? Okay. Define get offset. Why not? Get offset. Yeah, get offset. Self. And that's all we need because we are going to be getting our position from the X and the Y here. And let us get our offset. So, okay, so we're going to say return yeah, we don't even need to care about the XY right now, but let's say width minus, no, not width minus, tile size minus width tile size minus height. So if you notice that 80 minus that 136 is how we're ending up with the -56. So this is getting preserved. And why am I putting it in a tuple? Because that makes it easier for passing stuff in. And because I'm lazy. Okay. So Now, based on the size of the image, we can figure out where it should be put relative to the upper left corner of the tile itself. Sweet. So let's make a map denizen. Let's call it Katachi sprite equals map denizen. Map denizen. We're starting where again? Where are we starting? Did I say where we were starting? I'm put it somewhere. 1111. Okay. Map denizen. 1111. Katachi. 79. 136. Alright, time to check stream health. Oops. Come on. Looks like it says it's doing well. Okay, sure. Why not? Okay. So, now we have made a Katachi sprite denizen for the map. But he is not yet associated with the map. So we had better add him. So let's make a thing for adding an occupant. So for the map, asterism map, let us say I can't use the word map there. What shall I call it? Map grid. Sure, why not? Grid. Yeah, I'll leave that. Def. Occupy. Self. X, Y. Denizen. Yeah. And let us say that we're only allowed to do that if it's empty. So let's make a little helper function saying whether it's empty or not. Def is empty. Self X Y. Okay. So then we'll say return self dot map. And then remember, the first one is the row. Yeah, thank you, Merpler, or Muppler. Thank you. Okay, cool. All right. So we have to go into the row first because that's how the lists are stored. So I'm going to say Y first because that is our row value, and then X. And I know it feels weird, but that's how you do it. Occupant equals, should I say is none or equals none? Let's say is none. Okay, so this is going to say, do you have an occupant? No? Then return true. Yes? Then return false. Okay, so now I can use it to check if there's room for somebody to go there. So I'm going to say if hey, I finally found someone who finally got a stream. Cool. I have no idea who you are, but hi anyway. Yes, this is coding for a game, Mr. Shifro. Or Miss Shifro, or I don't know. I'm just going to call you Shifro from now on. If not is, if Wrong language. Not self dot is empty x, y. If it's not empty, I'm going to return and do nothing. I did, but I backpedaled. Sorry. Okay, so I'm going to return early if it's not empty because you can't go there if it's not empty. We don't have room for stacking because that would make things complicated. And I would like to make a relatively simple prototype for now, at least. Okay. Because most RPGs don't let you step on things anyway. Okay. So if we're not noping out early, we're going to actually add our denizen to there. So we're going to say self dot map. Once again, it's y and then x. Dot occupant equals denizen. Okay, cool. And there we go. So now we have a way to occupy a new square. So let us say Katachi's house dot occupy and 11 Katachi sprite. Now they are associated with one another. Sweet. Okay. Next up is what is next up? What shall I do next? Yeah, I know, right? This is very raw and real right now. This is how people actually create games with much of in the way of inarticulate sounds. Okay, so now that we have Katachi on the map, let's actually show him on the map. So map screen, that's where I want to go. Okay, 4. For row in, what did I call it? A map.map. For tile in row. So this is a double for loop, which we use because the list is 2-dimensional. So I'm going to first pull each row, which is the 19 wide thing, and then I'm going to iterate over every tile in there. So I'm going to say if tile dot occupant equal is none. Let's do that. Because we got our map tile in there. Yes, they are map tiles. So they have occupants or not. Okay. So if that is none, we don't do anything. So if not is none, then we shall actually add the sprite in question. So then If it's not none, then I need the image. So I'm going to say, I'm going to get the occupant, I'm going to get the image, and I'm going to add it. So I will say add tile.occupant.image. Where am I adding it? I am adding it in a position. Oh, let's calculate first. Why not? Offset equals tile.occupant.get offset. Okay, so I have an offset now. Tile left corner equals yeah, let's do it not that way. Okay, so for I in length of that, we shall say row equals a map dot map of I. So that's less shortcutty, but now I have the I, so it's all good. For J in, oh, not length, in range of length of that. In range of length of row. Okay. And then we shall make our tile declaration. Tile equals row J. Okay. If we have a tile occupant, our tile left corner equals a left corner X equals. Yeah, I'm not gonna call that. Let's call that off X, off Y. So, okay. So I'll get them both. And tile left corner X equals 80 times I. $80 times I plus offset X. Why? Because we don't need to know where we are relative to the image. We need to know where to go on the screen. And this is how we know where our left-hand corner of our map image, background image, goes on the screen. Plus offset X. Okay. And tile left corner Y. Have fun, Muppler, if that's how is indeed how you say your name. 80 times J plus offset Y. Yes, SLV, all my streams end up being on my channel for, on-demand watching whenever. I think that happens about a half hour after the stream is over. It depends on how long it takes YouTube to get its act together. But yeah, it happens automatically. Don't worry about it. Okay. This is wrong because I did it backwards. This needs to be J. This needs to be I. Because J is my position in the row. And I is my row number. Okay. So then, absolutely not. We are using static images here. I'm so sorry. I have what I have to work with, so that's what it is. But yes, the map will be moving relative to the sprite, while the sprite stays in the center. So, if that's what you're asking, yes, we're doing that. Add that at position tile left corner X plus our offset X. Tile left corner Y plus our offset Y. Offie. Okay. Cool. Let us see what that gets us. I think it is time for a test run. And if I have done everything right without any screw-ups, which is unlikely, we will actually get something without errors. Okay, so Katachi's house is our map, our big map, asterism map. So I'm going to feed that to the map screen, and I'm going to say show map screen, and then Katachi's house. Go away all this stuff. Okay. Show screen. Thank you, Zuzu. Show screen. Map screen. Katachi's house. Yep, and for anybody who needs a link and can't follow what Zuzu has given you, my channel homepage has the link, so you should be all good. And let us put a placeholder thingy so that it will not end the game before we can look at it. Okay. Asterism movement. It won't move yet. I haven't put that part in yet. Did I hit launch project? Yeah, okay, here it is. Hey! No syntax errors! Hey! Let's see if it actually works. Nope. Okay. Width is not defined. Oh, it's gotta be the self-taught width. I always forget that. Okay, so because we don't have width outside of this function here, the init function, we need to refer to it as self.width. Otherwise, it has no idea what we're talking about. I make this mistake all the time. Let us try it again and see if there are any other problems. Oh, look at that! Look at that! There's a Katachi! Looks like I gave it the wrong number for the tile number, but dang! Look at him! Look at him go! Now, of course, in the eventual, we were gonna have him be still when he's not moving, but this is progress. Okay. So let's put Katachi at an x of 10, an x of 10, and we start at the x of 10, and I probably can think of a better way so I don't have to put 10 in 3 times, but I don't want to spend a lot of time refactoring right now. Okay, let us see if that looks a little bit better. Yeah, that's better looking. He's at the entrance. Cool. Look at that Katachi go. Okay, so next up, let us try doing some artificial manual movement and see if that works properly. Now, this is not going to be smooth moves. This is not going to be an actual, he is not going to slowly move from one tile to the next. He is going to teleport to the next one. Because making the smooth moves is a little bit harder than that. And we can get to that later if we have time. Okay. So let us add some functionality to our map. Let's say we're gonna say def move to self x y off x off y, and yeah, okay, we don't need the denizen, it should already be there. Okay, so what does this mean? I'm gonna say this is, I'm taking whoever's at XY position and I'm gonna move them to the right this many and down this many. Okay, so we shall say if self dot is empty x y, we are gonna nope out of here because we don't have a denizen to move. Let's say move denizen instead of move to. Move denizen. Okay. Then we shall also say if x minus x plus off x is greater than self dot map and 0. What is that? We want the length of that. That's our 19 there. So basically, less than or equal to. Or if we run off the edge of the map, we don't want to allow that because that's bad. You fall off the edge of the world. That's no good. Okay. Or x plus off x is less than 0. We are going to nope out of there. If y plus off y. And I mean, yeah, I could combine all these, but I don't like making really long lines because it's harder to read, so whatever. If it is greater than the length of my map, so the number of rows I have, or the new position is less than 0. Why would it be less than 0? Only if off y is negative. Then we're going to nope out of there. If we have not yet decided that this is an illegal action or an action that does not make sense, then let's actually do it. Okay, so self dot map y x. Let us say denizen equals that dot occupant, and then let us say self dot map y x dot occupant is now none because you're leaving the square. Self dot if that's empty, and well, okay, we can do obstacle hitting later. Y plus off y x plus off, no, not off, off x equals denizen, oh no, not equals, the occupant equals denizen. I like that word. Okay, so if we don't have a denizen to move, then we do nothing. If we would go off the edge of the map. We do nothing. Otherwise, we teleport. Cool. $34 to $37. Yes. Okay, so it doesn't create a border or a wall around the edge of anything. It's just checking to see if the action in question, if the move in question would put you off the map. It is so that we do not, have a index out of bounds error, basically, from trying to access an index in the list that doesn't exist. So that's the whole point of it. Okay. Then all right, next up, let us say we're going to say Katachi's house dot move denizen. And where is he? He is at Katachi sprite.x, Katachi sprite.y, and let us move him up one. No, that's to the left one. Let us move him not to the left at all and up one. And let us put another placeholder there so that it does not nope out of the game. Okay, let us try it. What did I do wrong? Oh. Yeah, I should probably put that there. Okay, cool. Okay. So there's Katachi in his original position. Let us see if he moves. Or rather, if the map moves. Oh, he moved. Look at that, he moved. Okay. Why did the map not move? Because we forgot a very important thing, and that is to update the center X and center Y. Okay, so let us address that problem. Map denizen. Let us say if we just moved off our center, if self dot center X equals X and self dot center Y equals Y. If we just moved off of the center, then self dot center X equals X. Well, let's just say plus equals off X. So then we are moving to the new center. Self dot center Y plus equals off Y. Okay. Now let's see what happens. Okay, there he is. Look at there! He stayed in the same place, but the map moved. That is exactly what we wanted. Yay! Look at him dance. Oh, he's so cute. Okay. Alrighty then, what is next? Sweet. That is the whole point of this video, is for people to learn. Because so the backstory of this is that Miko is working on an RPG called Asters, and it's going to be really cool and constellation themed and all sorts of other nice things like that. And Miko is a college student pursuing a major in software engineering. And she was struggling a little bit with how to set up her map movement. And I figured if she, who is a software engineering major, is having trouble with this, then probably a lot of other people will too. So I decided I would help her figure it out, and then I decided later that other people could probably benefit from watching me figure this out too. Oh, cool. I'm glad you like the course. I will make more eventually. Sorry, I have way too much stuff going on. Okay. So, now that we have our movement when we do it artificially, the next thing we need to do is be able to make it so that Katachi will actually move squares when you like hit the arrow key or something. So I do not remember the key code for that, so I'm going to, yes, go away now. Ren'Py key map. What is, that's mouse down, key press enter, key return. Okay, so key return, that's our enter. We're gonna remember that for later. Left, right, up, down. Okay, cool. Alright, so for now, we're going to say left and right and up and down. One key press moves you one tile, just for the sake of simplicity. So, what we got to do is say in our map screen, we have got to add some key mappings. So K left, K right, K up, K down. Okay, that's pretty easy to remember. Doop 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 doop. Screens, where's my screens? Where's my screens? Screens in screen language. Key. No, wrong one. Sorry. There we go. Key. Okay. So this is what I want. Key. K up. Key K up will do an action. What is my action? Let's see here. We have a function. And how did we do this in the script? Okay, this is what we want. This is what we want. This is moving up. Okay. Map screen. Function. Katachi's house. Dot. Move denizen. Feed it. Katachi. Sprite. Dot x. Katachi sprite dot y 0 for the x movement and -1 to go up 1. Key K down. Action function, same thing as before except with different numbers. I should probably look at my chat to see if anybody's talking to me. Yes, I am on GitLabs. I like it. I like it so far. I just started with it a little bit ago so that I could do some backups without having to rely on the cloud as much, because I finally got my act together and started doing that. Yeah, it's pretty nice. Move denizen Katachi sprite.x Katachi. Oh, hold up. .y. You know what else I forgot to do? I forgot to change the location in Katachi sprite. So let's go back to here. Denizen dot x plus equals off x. Denizen dot y plus equals off y. Okay, cool. That should take care of it. Okay, back to the next one. Key. K left. Action function Katachi's house. I should use shorter variable names. Move denizen Katachi sprite dot x Katachi sprite dot y. -1 0 because we are moving to the left. And finally key K right. Why do I have so many messages on Discord? Action function Katachi's house dot move denizen Katachi sprite dot x Katachi sprite dot y 1 0. Hey, look at that. Okay, let us see what happens when I run it. Hey, no errors. Okay. Look at that, look at that, look at that. I can step on the island, but hey, that's because it's not coded as an obstacle yet. Well, it's not coded as an obstacle at all because it's a flat thing. Look at that, he doesn't go past the edge. Yay! Yay! You go up the stairs. Okay. I'm obviously having too much fun with this. Just dance on the fridge, Katachi. Whee! Okay. So, the next thing that I have noticed is that Katachi is always facing down and sometimes walking sideways and sometimes walking backwards. People don't usually walk backwards when they walk around. So, we gotta make Katachi change directions. Okay, that's enough of that. Alright, so the next thing we gotta do is add yet another action. And so that means we gotta make a list of actions. So we're gonna say set variable. That's because you're awesome, Joey. Not everyone is that awesome. We have front, back, left, and right. We want back as we go up. So set variable, what did I call it? Cater? Cater. Okay. Cater to be back. So that he will face the correct direction. Set variable cater to be front. This is down, right? Okay, yeah, front. Set variable cater to be left. Set variable cater. I can spell. I swear I can spell. To be right. Okay. Cool. Let us try that. Okay. Oh, look at him. He's facing the correct direction. Oh, look at him. Oh, what did I do? Oh. Apparently I can't spell. That's what the problem is. Katachi, when did I call you a knight? Okay, right. Okay, there it is. Okay, right. Okay. Let's try that again. Okay, Katachi, go, 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 go. You look at him walking. He looks realistic, sort of. Look at him go. Look at him go. He's so cute. Woo. Okay. You can tell that I like to have fun with my work. Whee. Okay. Okay. Enough of that. I am not coding outside. However, I have a really loud air conditioner. So that might have been what you heard. Coding outside sounds like fun, but it's kind of late right now to do that. Yeah. It's also kind of hot still. Okay, what is next? What is next? What is next? What's next? Let me look at my specifications. Okay, so we could try adding obstacles. We got the grid tile base, we got the character stays center and the map moves. Next up is adding other stuff to the place. Okay. So then okay, so I feel like I want to make walls that are not having an image associated with them. So like I want to make it so Katachi can't get on the sink without having to have a separate sink image. So in order to do that, so I need to make another class. The question is, do I want to make it the parent or the child of the denizen? And to me, denizen implies somebody alive. So let's say use denizen for the characters, and we'll just say class map occupant. That's as general as I can get right now in my mind. Self X Y and yeah, that's all we need. Okay. Self.x equals x. Self.y equals y. So this is going to be the parent class of denizen. So I'm going to say this is map occupant. And I don't need these x and y anymore because the occupant is going to take care of it. And how do I do that again? It has been a long time since I've done this. Let us look up Python inheritance. Super. What am I doing? Okay. Super. Base create. Okay, that's what I thought. Okay, wait. What is the difference? Super. Okay. we will use super because that I think is the more modularized thing, basically. So, okay, yeah. We shall say the wrong one. Super, what is it? I can't remember. Super, and then the class name and self. Okay, cool. Super map denizen self dot init. Yes. Init. And we will pass it X and Y because it wants X and Y. Okay. So then, now we have map occupants instead of just map denizens. So we're going to have to check and see whether we have an actual denizen before we add it to the map screen, because otherwise we don't want to show any images. Okay. If it's not none and tile.occupant instance of, is that right? That might be the wrong language. Python instance of is instance. Okay. Here. Okay. And actually, let me look at that more closely. Is instance object class. Okay. Is instance tile.occupant map denizen. Okay. So we are going to not care if it's just a map occupant, because if it's a map occupant, it is like the sink or something, and we don't care about that. So what shall I do next? Where shall I put the obstacles? I think I have to look at it again to figure it out. Okay, so yeah, I'm gonna actually play it to get a better feel for it compared to Katachi sprite. Yeah, okay. It looks like I didn't break anything. That's good. Okay. So this is 10. This is where I started, right? Yes, okay. So this is 1011. This is 1010. And this is 910. And all the other 10s are blacked. So let us put some obstacles. Okay. So first let's fix it so that everything is not starting at 1011. Let us make it at 1010 because that's actually on the map. On the map. 10, 10. Okay. Oh, super. Super is a shortcut for referring to the super class, or referring to the object itself as if it were only an instance of the superclass and not of the subclass. It basically means it's just saying go call this method on the on my parent class, basically. So the reason we need it is because if we just did init, we would call our own init instead of our super's init. So that's why we do it. Okay. And let's see, I moved those to there. Let us say wall equals map occupant and let's see, 910 was still valid. Let's do 810 just to have one for a proof of concept. And we'll say Katachi's house dot occupy 810 wall. Okay, so this should be not freaking out because we don't have an image. What it should be doing is keeping us from going to the 810 tile, which is the one just to the left of the entranceway. Okay, so we start there, we go there, we should not be able to go further left. Okay, so it looks like I screwed up. Okay. Okay. Alright, how did I screw up? This is 9, 8, 10. Why am I allowed an 8, 10? Okay. Okay. Why? It should have let me occupy. It wasn't empty, and it gave me the denizen, so it should have occupied it. Let us put some logging stuff there. Okay. Okay. Occupant, if I can spell, occupant equals Katachi's house dot map at row 10, column 8, dot occupant. Occupant flag, I shall call it, is none. So, okay, so this is going to once again check and see if we have anything there. And so I'm going to output that occupant flag there, and it should be true. And if it's true, then it means my stuff for checking if there's an obstacle is bad. And if it's false, then it means I didn't add it properly. But either way, we'll get more information. False. Okay, so that, I'm not sure whether to be happy about that or not, but it's helpful. Whee! Okay, bye-bye. So, occupant flag, oh no, it's false, which means it's not none. Okay, which means it is there. So why does it not go? If it's empty, oh, I didn't add that part yet, that's why. Okay. We need another nope clause here. If self dot is empty If not, self dot is empty. If our desired new square, so that would be x plus off x, y plus off y, if that is not empty, as in if we have a wall there, we are noping out. I forgot to do that part. Okay. Hopefully now it works. Okay. Hey, look at that! I'm pressing the left arrow key and I'm not moving. And look at that, I can't go this way either. Hey, I can go this way, but I can't go this way. And I can go this way, but I can't go this way. Look at that, I have an invisible wall. Hey. Okay. I am definitely not going to take the trouble to put all the walls in there. This is a proof of concept to show you how you would do it. Whee. Okay. What else is there to do? Oh, right, interacting with the cupcake. Interacting with the cupcake. Okay, enough of that. I'm distracted. All right. Let's see. I would like to have a thing for interaction. And okay, so I'm gonna say which line of code? This line of code? Oh, we could do it in a loop. It's no big deal. I'm just lazy, so don't worry about it. But you would have to have a separate occupant object in that map to say, no, sorry, there is something here. You cannot go here. Okay, so I'm going to say map occupant. And I'm going to make a thing called interact self. And it is going to do absolutely nothing because you can't interact with a wall. But if you are a denizen, then okay, so the thing is, having these different denizens means that you're going to want to have different behavior for pretty much each of the different objects, right? So if you talk to the old dude in the corner, you want him to act differently than if you eat the cupcake. We don't have an old dude for the corner, but you get the idea. So what I have to do is I have to have the denizen itself have an interaction function passed in. So I'm gonna say interaction. And I'm going to say self.interaction equals interaction. And then I'm going to basically say, hey, you're supposed to know what to do when somebody interacts with you, so go do it. There we go. It's a function. Okay, so that is the most general solution that I can think of at the moment. It is getting late, so my brain might just not be working. let's see here. Okay, let's make some interactions. I'm going to make a new file for that because there's probably going to be a lot if you actually do this for real. Interactions.rpy, and this will just be a repository of those functions. Init Python. Okay. Let's def a function and let's call it noop because it doesn't do anything. Ta-da! I made a function. Okay, so why do we need a noop? Because Katachi cannot interact with himself. Or, well, okay, yeah, I'm not going to make that joke. So when we make Katachi, he's going to have the noop as his interaction function. Because he is the interactor instead of the interactee. So it does not make sense for him to have an actual interaction function. So when we make the Katachi sprite, we must say noop in there. And yeah, okay. And then let us make a cupcake. Well, what should we do with the cupcake? Cupcake, we'll say... let's make a remove function. Occupy. Def unoccupy self x y. Okay. If self dot is empty. Actually, I don't even have to do that. I don't even have to do that. I can just say self dot map y x the occupant equals none. So even if it was none before, it's okay. It can be none now again. Okay, so let us make an interaction called disappear. Def disappear. Okay, we need the denizen. So denizen, because we need to know what we're disappearing. Okay. So let's change there. We gotta say we are giving self to the interaction. Okay. And let's say noop also takes a denizen, but we still don't do anything. Okay, disappear denizen. I'm gonna say Katachi's house. In reality, we would need to know and have somehow pass to us or keep track of what is the current map or what is our map so that we can actually disappear from the right place. But we only have one map right now, so I'm gonna be lazy. Katachi's house dot unoccupy denizen.x denizen.y. Okay, so then we have the cupcake, which will disappear because you ate it. And let's actually make the cupcake. Okay. Cupcake sprite equals map denizen. It is a denizen because it is interactable. Cupcake.png. Okay. Let us put it at 5, 5, why not? Okay. Not Katachi. Cupcake.png. And how big is cupcake.png? Cupcake.png is 35 by 26. It is a tiny thing. 35, 26. And disappear. Okay. And Katachi's house dot occupy 5 cupcakes. Right. Okay. Doop 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 doop. Let us see what happens. Doop 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 doop. Will I somehow have managed to do it right the first time? I don't know. Let us find out. Oh look, there's a cupcake. It's actually on a place that looks relevant. Woo! Okay, so I can't walk on it. Good. And oh, I forgot to put the actual interaction part yet. Darn. I was so close. Okay, so the map screen, we have got to say key, what was it, K enter? Enter, maybe? No, return, I think. Return. Action, and I'm gonna make a function. What am I gonna do? I'm gonna say, what I want to do is to check what direction Katachi is facing and try to interact with that particular object. Okay. So let's make a map utility function that will just be like def trigger interaction self x y if self dot is empty at x and y, we are noping out because there is nobody to interact with. If self dot map y x the occupant, actually let's just save that. Occupant equals that if is instance, oh no I don't have to do that because I have an interact for the parent class too. Okay, I don't need an if at all. Map y x dot occupant dot interact, because I got this interact thing here going. And so if I have the wall, nothing will happen because it'll just be like, I'm done. Okay. And that should be it for triggering the interaction. Okay. So back to the map screen, action. I'm going to make a utility function for this. It's too complicated to put an inline. Okay. I think I will put it in the Katachi. Init Python. I will put everything related to Katachi in here. We're just defining one function. Define. What shall I call it? It is to get the square that the tile that Katachi is attempting to interact with. So, get face tile? That sounds weird. Get facing tile? Well, let's do that. Get facing tile. And we shall say if Kader equals Katachi, yes, Katachi. If Kader equals front, we shall be looking down, so we're gonna say return Katachi sprite dot x. We're not looking left or right, so we don't have to alter that. And Katachi sprite dot y plus 1 because we're looking down. Okay. Okay. And this brings me back to the point of I gotta make sure I don't try to go off the map. So, gotta add these things again. If well, let's see. Let's put that in the is empty. Return x is okay, there. Formatting. X is less than 0, or x is greater than length of self dot map of 0 because that's my row, length of my row, or y is less than 0 because I can't look off the map either, or y is greater than or equal to but greater than or equal to length of self dot map, or if it's empty, then that should be returning true early and noping out. Okay, cool. Okay, cool. Oh wait, no, that's not good. No, I don't want to say that it's empty if it's off the map. Go away. Okay. I'll have to do it in here. Okay. If x, oh no, I gotta do that first. Because if x is less than 0, or x is greater than or equal to length of self dot map of 0. Nope. If y has the same problem, then nope. Otherwise, we can do it. Okay. Alrighty then. So then back to my Katachi function. So then even if we try to go off the map now, it's all good. Elif, which is else if, Kader equals. Well, I don't really need elif, but if elif, it doesn't really matter. Not in this context anyway. If it's the back, if we're facing back, we will say so. Katachi sprite.x, Katachi sprite.y minus 1. Elif Kader equals left. Return Katachi sprite.x minus 1. Katachi sprite.y. Else because I don't care about checking If somebody gives me a weird value that is not one of the actual ones, I will make the default be looking to the right, because why not? You gotta have a default somewhere. Right, that's why. Okay, cool. So I got my facing tile. Okay. Bum bum bum. And then okay. Let us say def Katachi interacts. And let's say xy equals get facing tile. And what did I call it over here? Trigger interaction. Katachi house.trigger interaction. Katachi's house.trigger interaction xy. Okay. And then finally on the map screen I have to actually call that function. Katachi, what did I call it? Katachi interacts. Okay. No, wrong one. Okay, there we go. Katachi interacts. And okay. Doop. What did I do? Oh, I forgot the colon. Darn it. I always do that with the else's. Okay. What did I do? Invalid key specifier return. Okay, fine. What is it called then? Customers into key map. What is return? What is return? What is it? 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 K return. Okay, fine. Or is it K enter? K return. Okay, let's do that. What happened to my plug? My computer is complaining that it is going to die. Oh, there it is. There's my power cord. Okay. Not return, but K return. Okay. Let's try it. Doobie-doo, it's a Katachi moving. Okay, I meant the cupcake. What happens if I hit enter? Oh! Look at that! I messed something up, but it actually attempted the right thing. So that is progress, and oh, I should probably make this a function call. Okay. Katachi, go eat that cupcake. Go eat that cupcake. Oh, oops. That was a space, not an enter. Oh, I'm facing the wrong way. Oh, what did I do? Occupant.interact. Okay. Why does it not? It doesn't have a get item? Oh, it's not map, it's self.map. I always forget that. Not map xy self dot map xy or yx. Okay. Enter. It works. The cupcake is gone. Oh, it works. Yay. Katachi, do some exercise to burn off those calories. I'm so happy. Okay. So. Okay. Enough of that. I have been streaming for how long now? Yes, Javier, it will be uploaded on YouTube. It's all good. You can drop out if you want. You will be able to catch up on it later. I'm almost done anyway, because it's late and I'm sleepy and my voice is disappearing. So, yeah. So, what did we do today? What we did today is we made a grid tile-based map exploration system. We made it so that the map moves under the character and the character stays centered. We made the enter key press next to and facing an item interact with the item. And then we also made obstacles that you can't interact with, that you can't go onto. I think, Miko, that should be enough to get you started on this. Feel free to adapt how you want, and hope this was helpful. Alrighty, I am signing off for the night. Bye, everybody.